Example 3 is find two values for theta on the interval between 0 and 360 degrees if sine theta equals -1 over root 2. Another way to do this, or another way to state this question, would have been to say simply solve the equation sine theta equals -1 over root 2 within the first cycle, or between 0 and 360 degrees. So they didn't actually have to tell us that there was two answers. We would have to know that based on the cast rule and special triangles. So the first thing is that sine is negative. So if the sine ratio is negative, that means it's going to be in the bottom two quadrants, because that's where sine is negative. So we're going to have an angle here, and we're going to have an angle that has a terminal arm right there. The other thing that we know is that the opposite side is 1, and the hypotenuse is root 2. So if you look back at your special triangles, which angle has an opposite side of 1 and a hypotenuse of root 2? And that is our 45-degree triangle. So we know that our related acute angle is 45 degrees. So I know that there's going to be 45 degrees right here, and I know there's going to be 45 degrees right there. Okay. So now that we know all that information, we're actually pretty much done. We just need to calculate the actual angles here. So our first theta is going to be going all the way around here. So to find it, we're going to do 180 degrees, which would take us to this line, plus an extra 45. And that would give us 225 degrees. So that is theta 1. Okay. And then the second one, theta 2, it's nearly a full 360 degrees. It's just 45 degrees short. So to find that angle, we're going to say 360 degrees minus 45 degrees. And that gives us the angle of 315. So there are our two possible answers for theta. In fact, those are all the possible answers for theta within the first cycle. Our last example here, it says for theta in the standard position with its terminal arm in the fourth quadrant. So let's draw that out before we do anything else. So the terminal arm is in the fourth quadrant. Cos theta equals 7 over 25. Find the exact values of sine and tan. Okay, so we want to find sine theta, which is going to be y over r, and we want to find tan theta, which is going to be y over x. And they gave us cos theta, so they gave us x over r. So we have the x, we have the r, we need to find y. So we can use the equation x squared plus y squared equals r squared, and we can sub in what we know to solve for y. So 7 squared plus y squared equals 25 squared. Y squared would equal 576. And if we square root that, we would get 24. And more specifically, we would get negative 24. Because whenever we take the square root, remember, we can always take a plus or a minus. And because we're looking at this fourth quadrant, we will take a negative y value because y is negative in that fourth quadrant. So now we can actually find the exact values for sine theta and tan theta. So sine theta is y over r, so it's going to be negative 24 over 25. And tan theta is y over x, so negative 24 over 7. Okay. If we hadn't noticed that the negative should be on the y, then you would have gotten positive answers for sine and tan, but this is the cosine quadrant, so we know that only cosine can be positive, so the other two had to be negative in the end. So that is our last example for this lesson. so you guys can try the homework.